and then y is going to be the 4. We need to find the r and the theta for this. So the r comes really easy just from this equation. R squared is going to be the x component, 4 square root 3 squared, plus the y component, 4 squared. 4 square root 3, squaring the 4 is 16, squaring the square root of 3 is 3, 16 times 3 is something, 48 I think, and then plus 4 squared, 16, those add together to be 64. And then remember that's what r squared was, so just taking the square root, we get 8. We do not have to worry about the plus and the minus because the question itself said that our r's have to be positive. Okay. We also have to find the theta for this, and we get the theta from that tangent theta is equal to y over x. So for us, our y is 4, and our x is that 4 square root 3. All right, the 4's cancel, and we just get 1 divided by the square root 3. And if you want to fix that, you can. That's square root 3 over 3. Okay, at this point, you have a couple of options. You could just do the inverse tangent of the other side, and hopefully it'll spit out a nice number. The problem is that we're in radians here, and the calculator really struggles with radians. Square root of 3 over 3, or 1 over root 3, these are nice numbers on the unit circle. So let me pull up a unit circle here. See if I can make it big. There we go. All right, so the other part of this is that you have to make sure you're in the right quadrant of the unit circle because there's 2 different locations where tangent is positive 1 over square root 3. So if we look in our x and our y component of the point 4 root 3, 4, these are both positive. And since they're both positive, that says we're in quadrant 1. So we need to look in quadrant 1 where tangent is 1 over the square root of 3. So just looking at it, it looks like it has to be this one here at pi over 6. Because if I take the y value 1/2 divided by the x value square root of 3 over 2, I get that 1 over square root 3. From the unit circle, theta is that pi over 6 thing. All right, and then just to type it into the homework. The polar coordinates are the r value 8, and then the theta pi over 6. Cool. Yeah, and so you just do that process for these other 2 as well. So just to do them a little bit quicker. So the next point there is negative 2 square root 3, 2. So again, the x value is going to be that negative 2 square root 3. And then the y value is going to be positive 2 in this case. So we're going to find our r value by doing r squared is x squared plus y squared. So for us, that's going to be negative 2 square root 3 all squared plus 2 squared. Which is squaring the negative makes that positive, and then 2 squared is 4 times square root 3 is 3. 4 times 3 is 12, plus the 2 squared there is 4, so we get 16. And then we have to take the square root of that to get the r value itself, so our r value is just going to be 4. Finding the theta, we're going to do the same thing. That tangent of theta is going to be equal to the y value 2 divided by the x value, that negative 2 square root 3. So the 2's cancel, but we still end up with a negative sign. So I'll write it like this. Negative 1 over square root 3. And again, we're looking back at the unit circle. But we have to be in the right quadrant. Our x component is negative. Our y component is positive. That says we're in quadrant 2. So if I look at the unit circle, in quadrant 2, my tangent was negative 1 over root 3, which looks like it has to be this one here at 5 pi over 6. All right, if I take 1/2 divided by the negative root 3 over 2, I get that negative 1 over root 3. So that's going to be my angle theta. It's 5 pi over 6. All right, and then, yeah, just going back to the homework question. So my R value was 4, my theta, 5 pi over 6. Okay, cool. Yeah, and then the last one's the same thing.
I think I understand. If you don't want to, we don't have to do the last part.
Okay, yeah, so it's just the same steps to get that one. Okay, any other homework questions from this chapter 11 stuff? Anybody? Any questions?
On 11.5, could you kind of maybe do a problem like one of the first ones?
Yeah.
To go over like the limits of integrating?
Yeah, sure, we can do that. So for this first question, like it already gives you the limits of integration for the angle 0 to pi. So let's look at the second one, just because they don't really give you much information for the second one. So find the area inside one loop of the whatever you pronounce that. R squared is 6 sine of 2 theta. Okay. So it's kind of hard to know what this thing is going to look like without using your calculator to help you. And unfortunately, I can't like put a calculator on my screen necessarily, but I can kind of talk through the steps. Just like with normal equations, if it's a squared, you're going to have to take the square root and you're going to have to do the positive and the negative. But in your calculator, anytime you want to graph a polar equation, you have to change the mode. Do you have a calculator there with you?
Yeah, I'll get it.
Okay. So you want to change the mode to polar form. So just go into the mode button of the calculator and you'll see polar somewhere there. Just select it. Then go into the y equals button. And in the y equals button, there'll be r's instead of y's everywhere. So r1 equals something, r2 equals something, and then blah, 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 blah. So because we're having to take the square root, we're actually going to have to graph two different ones. We're going to have to do the square root, the positive square root of 6 sine of 2 theta. And then the negative square root of the same thing. Yeah. So if you just type it in like this into the calculator, into the y equals stuff and graph, it should give you what the graph looks like. Let's see if I can open up like Desmos or something to see what the graph is going to do. Hopefully it'll graph it without too much issues. R squared is 6 sine of 2 theta. Graph. Or at least we're going to have to do the same thing. So R equals 6. So that's R equals the positive 6 sine theta. Or we need the square root, don't we? Sorry. Square root. 6 sine 2 theta. And then we also need to do r as the negative square root of 6 sine 2 theta. Cool. And it looks like they just kind of double back on themselves, right? Like if I get rid of the green graph and I just do the positive version, I get this kind of diagonal infinity sign. If I add on the negative square root, it just loops back over the same thing. So r equals the positive square root 6 sine 2 theta, and r is the negative one. We still get the same graph from 0 to 2 pi. Where it may be kind of weird is if we just change this to be from 0 to pi, and then maybe this one from 0 to pi. Yeah, so notice how like one of them does one loop and the other does the other loop in the first 0 to pi range. Okay, anyway, the point doesn't matter, though, so let's go back to the question. So we just want to find the area inside one of the loops of this infinity sign graph. So going to the integral now, first off, whenever you're finding the area inside of a polar equation, there's a formula for it. The area is going to be the integral 1/2 r squared d theta. So that's just coming straight from the book or from the video that I made for this section. If we're finding the area of just one of the loops, again going back to the calculator's graph or to the Desmos graph, and unfortunately you have to graph it to kind of visualize what it is that you're trying to find. So going back to my graph here, if I'm just trying to find the area in one of the loops, it looks like I can just do the positive square root 6 sine 2 theta and then going from 0 to pi, because that makes one full loop. You just have to play around with the inputs and then seeing how far it goes. You can do that in the calculator as well, like playing around with the limits, if you go into the window button in the calculator. So if you go into the window button, it should say something like minimum theta and maximum theta, and you can plug in where you want your calculator to graph your limits from. So just try graphing from 0 to pi, and you should be getting the same graph I'm getting here with just one of the loops.
Okay. Yeah, thank you. So, like, on the test, are you gonna give us those limits, or are we gonna have to like graph it ourselves on that?
Yeah, sometimes you may have to graph it yourself and figure out the limits on your own.
Okay.
So just to finish the question, right, we're going from 0 to pi now, 1/2, and then my r is the square root of 6 sine of 2 theta. And it's that thing squared, d theta. All right, so squaring off the square root just makes that go away. We end up with the integral 0 to pi so the 1/2 is going to cancel out with the 6 to be a 3, and then we have the sine of 2 theta on the inside, d theta. That we should be able to find the antiderivative for without too much issues, because the antiderivative is, you're going to bring a 1/2 out, and the antiderivative of sine is, I think it's negative cosine. And then we're evaluating this from 0 to pi. If I plug a pi into this, that's going to be cosine of 2 pi, which is 1, so we get negative 3/2. That minus, if I plug 0 into this, we also get cosine of 0 is 1, so another negative 3/2. It kind of looks like, uh-oh, did I goof up somewhere?
It's okay. I get the point. I just got confused, like, on the limit stuff and trying to like figure that out. But
right.
I get the rest of it.
Okay, yeah, just from the integral, it shouldn't be too bad. But unfortunately, the only way to get the limits is by looking at the graph, and it's hard to graph those polar equations without using a calculator. So just make sure you have the calculator with you and graph them in there.
Okay, thank you.
Mm-hmm. Well, now I'm bothered with my answer. Because I'm getting 0, but it's definitely not 0. Oh well, I'll just not sleep tonight, I guess. I have to separate the integral. Oh, so you do have to do that? So you're saying to do like from 0 to pi over 2 and then pi over 2 to pi, splitting it up like that? That seems weird. See what the viewing example says. Oh, okay. I see. Yeah, so another problem with graphing stuff like in the calculator and everything is that my graph doubled back on itself. So if I just graph from 0 to pi over 2, I get the loop, which also if I graph from 0 to pi, I get the same loop. And the reason I'm doing that is because the way that this is graphing is that it does the loop and then it kind of loops back on itself. So the reason that I was getting 0 was because I was counting the loop twice. Really, I should have been going from 0 to pi over 2 for my limits. All right, and now it'll work out to be like 6/4 or something like that. Okay, so that was my mistake. Again, and that's just part of the problem of having to be very, very particular with the limits. Because unfortunately with these polar equations, they do loop back on each other. So if you figure out the loops, you may want to try cutting it in half or cutting it in fourths to still see if you get the same graph. Because you only ever want to integrate over it once. You never want to integrate over it twice, like I was just doing. Cool. Okay, yeah, so sorry I messed that one up, but that's the gist of it. You just have to use a calculator or Desmos if you have it in front of you. Is there any other questions from the homeworks? I did pass out or email out that the practice exam, right? The one that's all worked out. I think I did.
Yes, sir.
Okay.
Yes, sir.
And then, so I also put this up. I'm sure you've seen it there in my math lab, this final exam practice. And I put a ton of questions in it. So it's got 73 questions. It's not graded. I do not expect anybody to go and do all of those questions. It's just kind of for us to work through it. And then, on your own, if you see a question that you're unsure of, then you can go to it and hit the view an example and kind of get some help on some questions you may not recognize. But is there anything else? Is there any other questions you guys have before the Chapter 11 test next week? I do encourage you guys that when you do finish the test, to make sure you put your scratch paper up on Moodle. It does help out a lot for partial credit.
How many questions is this next test?
I don't know. Let me look. I don't remember it being very much. I don't want to go into that. 14 questions. Last call. Any other Chapter 11 things? Everybody feel pretty good about the test? Most of them would be short. Like, most of them are just converting, Cartesian to polar, or converting from the parametric to Cartesian stuff. But you will have some integrals like this, where you're finding the arc length, or if you're finding the area of those polar equations. I think there was some arc length stuff for the Chapter 11 stuff from the earlier stuff. You'll also have some questions where you're trying to find those slopes and the equation of lines from the parametric equation stuff. Those could be kind of hard. I think that's pretty much the majority of the questions, though, are arc length, area, and then derivatives of the parametric equations, with a little bit of other stuff penciled in. Anything else? We don't have to stick here around for the whole hour if you guys don't have any other questions. I think next time I'm going to start looking through this practice stuff. So probably this Thursday, I'm just going to kind of open this up and then just go question by question and work through quite a few of them. Because I know it's been a long time since anybody's looked back at Chapter 6 or Chapter 8 stuff. So I'm going to start off there. And if you can't make it Thursday, I'll record going through that, so you can always watch it later through Moodle. Okay, well, if there's no other questions, let's head out. I'm gonna go get some lunch. I think there's an orange in the fridge with my name on it. And hopefully you guys can come Thursday. I'm gonna try and do like a lot on Thursday, working through that practice exam here online. Or maybe I'll just do Chapter 11 stuff from the practice exam, just to help you guys prepare for the Chapter 11 test. Maybe I'll start there and work through it backwards. Okay, thanks for coming. Bye. See you guys later.
Bye.
If you have any other questions, just send me an email.